Swayam Prabha, free DTH channel for education.
A into y power multiply this one, so you are going to get y power y minus a y power a, so it is going to cancel, so you are going to get 1 minus a into r minus 1 minus a into multiply here, so you are going to get p into y power 1 minus a is going to come, okay, that is nothing but 1 minus a into r minus 1 minus a into p into y power 1 minus a, which is nothing but q. So I can write this as u dash plus 1 minus a into pu equal to 1 minus a into r. So this is same as this one. Okay, you can solve this problem. So u dash, in the place of p you have 1 minus a into p, in the place of y you have u, so u is there, and in the place of r you have 1 minus a into r is there. So this one you can solve and then you can apply the solution problem. Okay. So let us solve a simple problem for that. So we have the problem. So I have, if so next one, I just write this Bernoulli equation. So Bernoulli equation is of this form: y dash plus p of x, p into y equal to r into y power e. Okay, so in that case I got to solve u dash plus 1 minus a into p equal to 1 minus a into r. I got to solve, and then I can apply the solution. This is called Bernoulli equation. So let us solve this problem. So let us solve this. So you are going to get, so let us solve this problem: x into y dash, okay, x y dash plus y equal to x square y square. Yeah, x square y square. So this I can write as y dash plus y by x equal to xy square. So this is the Bernoulli form. So what is p? P is 1 by x. Okay, and what is a? A is nothing but 2. Okay, and what is r? R is nothing but x. Okay, therefore what is my equation is going to be u dash plus 1 minus a, that is going to be 1 minus 2, that is going to become like minus. Okay, and p is nothing but x, so minus u by x equal to 1 minus a, which is nothing but once again minus, and then r is nothing but x. So this is going to be my equation. Okay, so u dash minus u by x equal to minus x is there. So I can just find the answer for this problem. Okay, so what is it going to come if you solve this problem? Okay, and what is your u also I can write it. U is nothing but, okay, here u is nothing but y power 1 minus a. So here u is nothing but y power 1 minus a. Okay, so y power 1 minus 2, which is nothing but 1 by y. Okay, so you solve this problem. If you solve this problem, u is going to become like e power minus p dx, so it is going to be 1 by x dx, okay, into e power integral, once again 1 by minus and minus plus will come. So here it is going to be minus 1 by x into dx into r of x, which is nothing but minus x, okay, integral minus x into dx plus some constant is going to come. Therefore this is going to become like e power ln x, okay, and this is going to become like e power minus ln x into minus x dx plus c is going to come. Therefore you are going to get x into e power minus ln x. Therefore this is going to become like 1 by x. So 1 by x gets cancelled. So you are going to get only 1 is going to come, dx minus dx plus c is going to come. Okay. Yeah, minus c is going to come. So you are going to get minus x square plus cx is going to come. Okay. So u is this one. Therefore u is 1 by y. Therefore y equal to 1 by cx minus x square, or minus x square plus cx is going to come. Okay. Now we have one more concept called autonomous ODE. Okay. In autonomous ODE, what we are going to deal. Okay. So this is a particular case of Bernoulli equation. Okay. We are going to get some of the Bernoulli equation, or we'll say like it's not particular case, I will say. So sorry. Now we are going to deal with autonomous ODE. In autonomous ODE, so what we are going to deal with that, we are going to deal with the problem of this type. So we have, earlier I said y dash equal to f of x comma y is our problem. we have already dealt one case called y dash equal to f of x we got dealt. But we didn't deal this case y dash equal to f of y case. Okay, so this case we already deal. Now we are going to deal this case y dash equal to f of y. So if y dash equal to f of y, if we can write that ODE in this page where x is not occurring at all, then that ODE is called autonomous ODE. Okay, so this case is very simple case. You can simply integrate and then you can find. And this case is called autonomous ODE. For this ODE, what we have is like if this ODE has a constant solution. Okay, if this ODE has a constant solution, these solutions are called equilibrium solution, and those points are called equilibrium points. Okay, so equilibrium points are applied. So when this is going to have a equilibrium solution, if y dash equal to y is going to have a constant solution, that means y dash equal to 0. That means f of y equal to 0. Okay, so if y equal to constant, then you are going to have y dash equal to 0. That means f of y equal to 0. So if f of y equal to 0, you are going to solve this. You are going to find the roots of this equation. F of y equal to 0. You got to find the roots or zeros of the equation f of y. So that is going to give you y dash equal to 0, and that is going to give you y equal to c is going to come. So the zeros of the function, okay, the zeros of this function f of y is called the critical points of this autonomous ODE. Okay, that is called critical points. Also, suppose you are equilibrium solution. So if you obtain the equilibrium solution, if this equilibrium solution is called stable, then it is going to be stable. If the solutions, okay, the solutions whatever you found, okay, suppose you have the solution, you found the solution. Suppose you have a critical point over here. If the solution which you found is close to it for some x, is going to be close to it for all further x. Means suppose you found a solution which is going to be here, okay, and you move from here, and your y should not jump somewhere here. That means you are going to move very far. Suppose I have x here, okay, and I close to this. If it is going to have something very large jump is going to be there, then that is going to call as a unstable. It is not going to be stable. Okay, if I just move from here further x also, it is going to be moved from here, and I have some bound for this one. Okay, if it is going to oscillate something here, then I say that is a stable one. If it is going something like this one or something like this one, okay, it is going to move very far from this place, then we say that it's a unstable solution. Okay, so unstable means whatever you choose initially, that should remain close to it as t increases or whatever you're doing for the other. Okay, so that is called stable and unstable. Okay, so this is one of the important thing for many of the engineering application, because whenever some problem is given, you need to check whether you are going to get a stable solution or unstable solution for your system to be consistent, or you have to have some kind of stability, etc. Okay, so the following equation is called the logistic equation. It plays an important role in population dynamics. So you have dy by dt, okay, equal to ay minus by square is going to come. Okay, so this is called logistic equation when where a and b are constant. So you can see that this is of this form, y dash plus py equal to r of y. Okay, so here there is a is constant, there is no p of x, so a is constant, b is also constant. Therefore, this is nothing but f of y, which is nothing but ay minus by square. So I can find the equilibrium solution. So if it is equal to 0, then I can write this as y into a minus b y equal to 0. So these roots are going to be y equal to 0 is one root, and y equal to by, so a by b is going to be one solution. Okay, y equal to a by b and y equal to 0 are two roots of the function f of y. Therefore, these are called critical points. The critical points are y equal to 0 and y equal to a by b. Clearly, y equal to 0 is a solution, because you can substitute here y equal to 0, y equal to 0, and dy by dt is going to become 0. So it's a solution. Okay. Now we got to find the second solution. Okay. So suppose that is not there. Okay. So we can find that this is a logistic equation. You can solve this problem, and then you can find the solution for this problem. I just leave it as an exercise for you. You can find that solution that is going to become like the second using the Bernoulli equation. You can find the solution for this one. That is going to become like 1 by c into e power minus a by at, okay, at plus b here plus b by a is going to come. Okay, you can solve that very easily. Okay, you can solve the problem and you can obtain the solution for this. So you can see here, this is called the logistic or population balance equation. So Ty by dt equal to A. Suppose your B is 0. Okay, suppose B is 0, then what you are going to get? Ty by dt is going to become like A. So in this case, you can observe that the solution is going to be e power at is going to come, means you are going to get complete growth is going to come. Okay, complete growth is going to come. Means the population is going to keep on increasing. But it is not the case because we have deaths and other calamities are there that is going to control the population growth. So in that case, this y equal to minus by square is going to prevent the population growing without bound. Minus by square is not there, the population is going to increase like anything. Okay, so this minus by square is controlling the population without growing much further. Okay. So initially the small population keeps on growing. Okay, see, small population keeps on growing, and after certain stage people will be getting aging and other things, so they will be dying. So that is going to control over this one. So initially the small population keeps growing as long as this is going to happen. Unless y is less than a by b, you can see that this equation you can write it as y dash equal to y into a minus by, you can write it. Okay, so this is going to be I can just write this as, I can take b out, so this I can write as by into a by b minus y, I can write it. So in this case, if y is less than a by b, if y is less than a by b, you can see that y dash is going to be greater than 0. Okay, y is less than a by b means y minus ab is going to be, or a by b minus y is going to be greater than 0. So y is less than a by b means a by b minus y is greater than 0. Okay, so in that case you can see that this is p is positive, a by b minus y is positive, therefore this is y dash is going to become positive. If y dash is positive, that means it is going to keep on increasing because it is y dash which is going to be a increasing one. Okay, it keeps on growing. Okay, on the other hand, suppose we have y is greater than a by b. Okay, y is greater than a by b, which implies a by b minus y is less than 0. So that means it is going to keep on decreasing. Okay, so similarly the population is decreasing as long as y is greater than a by b. So you can solve this. I give this to as an exercise. You can solve this logistic equation. You can obtain the equilibrium solution of this logistic equation, and you can discuss the stability and instability of this logistic equation. Okay. Finally, we are going to deal one more thing called existence and uniqueness. So existence and uniqueness is going to solve some of the important things for you, because so far what we did was we just solved this, we did the formula and then we used that one. But what is the guarantee that the solution is going to exist, or what is the guarantee that you are going to get the uniqueness one? So already we have dealt with, for one case, for example, dy by dx equal to r of x. In that case, we have said that existence or uniqueness. If this r of x is continuous, then we have said that using the fundamental theorem of calculus, you are going to get the solution of the problem, and then you are going to get the uniqueness is going to come. But in general, what you are going to have, you are going to have for the general setup like y dash equal to f of x comma y, okay, and y not equal to y of x not equal to y, okay, y of x not equal to y naught. So this initial value problem, for this initial value problem, we are going to check whether the solution is going to exist or not. I'm not going to give the proof of this theorem. I'm just going to state the theorem. So the initial value problem, what we need to consider is that we need to consider when the solution is going to exist, or what is the condition we need to impose on. Okay. So condition number 1. Okay. Suppose f is continuous. Okay. F of x comma y is continuous on some rectangle R. The rectangle I am giving it as, okay, R is nothing but x minus x naught less than a and y minus y naught less than b. Okay, I have given this rectangle. Okay, so in this rectangle I have, so means what I have a rectangle. Okay, so x minus x naught is less than a means I have a here, I have x naught here. Okay, and I have x naught minus a here and x naught plus a here. Okay, similarly I have b here, y naught here. Okay, and y naught minus b here and y naught plus b is here. Okay, so I have a rectangle. This is my rectangle. Okay, So in this I have defined my I said that my f of x is continuous. F of x comma y is continuous. F is continuous on the some rectangle this one. And I have second condition. Okay, second condition is it is bounded. Okay, second condition is it is bounded. F is bounded. Bounded means what? I have f of x comma y is less than k for all x comma y in the domain R. Okay, in this rectangle. In this rectangle, it is bounded. Means if I just take the f of x comma y, it is going to be a surface. That surface, what I am going to cut, that surface is not going to grow like anything. Okay, it is going to be bounded. So f of x comma y is less than k for all x comma y branch or less than equal to k, where k is some fixed number. That is a number case which that this is going to be done. Then this theorem, this is called existence theorem. This existence theorem is going to say that if this is there, f is continuous and f is bounded, then this theorem is guaranteeing is that at least one solution is going to exist. Okay, this initial value problem has at least one solution. I don't know whether you are going to get many solutions, but at least one solution is going to exist. Okay, so that's what it is going to do. And further, it is going to claim that the solution exists not everywhere. It is not going to exist everywhere. The solution exists for all x in the subinterval. Okay, in the subinterval. So it is going to exist in the subinterval x minus x naught less than alpha, where alpha is nothing but minimum of a comma b by k. Okay, there alpha is minimum of a comma b by k. So that means bar I have suppose alpha equal to a. If alpha equal to a, that means my solution is going to exist everywhere here. Okay, I mean in this interval it is completely going to exist. But if alpha equal to b by k, if it is not minimum, then what I am going to have? I am going to have something like b by k here. Only in this small rectangle it is going to exist. Okay, so this is, let's say, b by k. Okay, this is minus b x naught minus b by k. This x naught minus b by k, and this is x naught plus b by k. Okay, so in this interval only, so we are going to get something over here only. You are going to get. Okay, so that means you are not going to get everywhere. You are going to get only at few places where this solution is going to exist. Okay, in small rectangle you are going to get it. Okay, so this is the one it is guaranteed. Now, for uniqueness, what we need is we need one more condition. Okay, so for uniqueness theorem, we need one more condition. F of x should be continuous. F is bounded. Okay, now we got to impose one more condition for uniqueness. For existence, we have this one. For uniqueness, what we need is we need one more condition. Condition number 3. Okay, actually two conditions are required. Okay, one more condition is that we require this fy is also continuous. Okay, partial derivative with respect to y, it should be continuous. Fy should be also continuous. Condition number 4. Okay, not only that fy is continuous, what you need is that this fy should be also bounded. So there should be some m such that this fy should be less than or equal to m. Okay, fy of x comma y should be less than or equal to m for all x comma y in R. So these 4 conditions are required in order to satisfy that this is going to be continuous. This is going to be have a unique solution. So in that case, what I say, not only at least one solution. Okay, I am going to say here I am going to say at least one solution. Here I am going to say at most one solution. Means uniqueness is going to come. Okay, at most one solution is going to come. Okay, so this solution exists at least for all x in again the same interval. Okay, this solution is going to exist for all x comma x minus x naught less than alpha, where alpha is given in this way. Okay, minimum of a comma b. So this is going to guarantee them. In fact, what you can do is that this condition number 4. Okay, this condition number 4, you can replace that, or you can relax that condition, or weaker condition we used to say. Not only that, fy less than m you require, you can relax that condition, because what is the definition of fy? Fy definition is nothing but, okay, we know the fy definition. Fy definition is nothing but f of x comma y1 minus f of x comma y2 divided by y1 minus y2. Okay, y1 minus y2. So when y1 is approaching y2, you can say that we are going to get f of partial derivative of f with respect to y at the point y1 or y2. We can say, okay, y1 approaches y2 or y2 approaches y1. Now what we are going to do is that we are going to we are going to replace this condition, which is a stronger condition. Fy is less than m. We are going to replace that with this condition. Okay, which is less than or equal to m. So that means I require that f of x comma y1 minus f of x comma y2 is less than or equal to m into y1 minus y2. This condition is called Lipschitz condition. If this condition is satisfied, then also you can say that this is going to have a unique solution. Okay, this can be replaced. So let's say a simple problem. So suppose we have only continuous. Okay, suppose we have only continuous. That is not going to guarantee the uniqueness. Okay, if you have continuous, it is not going to guarantee the uniqueness. So for example, consider the initial value problem. So you have f dash of y dash equal to square root of y. Okay, so let's consider this problem. Y dash equal to square root of y and y of 0 equal to 0. Okay, so in this case, what is going to happen? You know that this function is going to be continuous. Okay, f is continuous for all y. Okay, however, what we are going to have is that we are not going to have a unique solution for this problem. Okay, let us see that. So for the problem is that I have f of x comma y equal to square root of y. Okay, this is my problem. Okay, so f is continuous. You can prove that f is continuous. Okay, for all y. Okay, however, you can see that my problem is y dash equal to square root of y. Okay, and y of 0 equal to 0 is given. So y equal to 0 is trivially a solution. Okay, y equal to 0 is a solution and it is a unique solution. Okay, it's a sorry, not unique solution, it's a solution. Okay, y dash equal to square root of y, y of 0 is that, therefore y equal to 0 is a solution. Okay, so I just called as y1. Now y2 is equal to, define y2 is equal to this way. Okay, y2 is equal to x square by 4 when x is greater than or equal to 0 and minus x square by 4 if x is less than or equal to 0. Okay, so at x equal to 0 it is going to be either equal to. So in this case you can check that what is your y2 dash. Okay, y2 dash is going to be you are going to get it like 2x by 4. Okay, 2x by 4 is going to come. Okay, so you can just take that. So this is going to be square root of, so sorry, this is going to be x by 2. Okay, this is going to be x by 2, which is nothing but square root of y, because x square by 4, x square by 4 is nothing but x by 2, which is that. Now if you take y2 in the other side, okay, this is also going to become like y2 dash. On the other side, this is going to become like minus 2x by 4, and again you can take modulus of y, that is going to give you the same kind of answer is going to. Okay, so therefore what you are going to get? You are going to get y2 is also a solution, y1 is also a solution. Therefore, you are not going to get a unique solution for this problem. Okay, so the two solutions of IDP are there. Therefore, y is f of x y is continuous is not enough to satisfy them. So I give some more exercise problem. So which of the following equations have unique solution? You can check it. Okay, what are the I have given some 6 exercise problem. You can check what are the problems are going to have unique solution. Okay, if it is not having unique solution, which condition is failing also you can state it and then we can find. And here again one more problem. Okay, determine the region of xy plane for which the given ODE would have a unique solution whose path passes through x0, y0 in the region. Okay. Okay. So with this, I stop the lecture and let's continue the next one in the next class. Thank you.